Hi, I'm Jiska,
Hi, I'm Alex, and I will be your training assistant.
and we are teaching this new iOS reverse engineering training for you. As iOS security researcher, pen tester, or malware analyst, you'll oftentimes encounter questions that nobody has answered publicly before. With this training, you will get the basics that you need to understand the iOS ecosystem, as well as a ton of tools and how to use them, which you will need to also understand all the undocumented features or any new features that Apple will add in the future.
Diska and me have both supervised a lot of theses where students reverse engineered and analyzed Apple binaries for the first time. From these, we know how to get you started and make you stand on your own feet. We made this training beginner friendly by explaining the most important basics but have a steep learning curve to include new contents for everyone.
This training has many hands-on reverse engineering exercises. We start with the application layer and then go all the layers down to firmware and coprocessors. We start with looking into an app which has a highly privileged app extension, and from there on we will understand developer documentation, then extract the application from a jailbroken iPhone and decrypt its binary to analyze binary and also understand its permissions. And now to my favorite tool, Frida. With Frida, we will write merge hooks to understand the inner workings of the app. And then we will use Frida to write a coverage-guided fuzzer to trigger a bug inside the app. We will then analyze crash logs to understand what caused the bug and how to fix the bug. So with this tooling, you are already set to pen test apps on your own. There's a lot more that helps you with reverse engineering iOS apps. In this training, you will learn how to reverse engineer Swift and Objective-C binaries, how to extract the DYLD shared cache, how to follow asynchronous calls being made with Grand Central Dispatch, and also how the app extension and system daemons communicate over XPC. Then we leave user space and take a look into the kernel and its interfaces such as Mach messages, syscalls, and IOKit. While some parts are open source, everything that interests us is closed source, such as some security critical parts, as well as drivers and how to interface with them. We look into one of the drivers and figure out the arguments to call it from user space. More and more components on Apple devices are moved into coprocessor firmware. These coprocessors take tasks that are either performance critical or that need compartmentalization for security features. We will take a look into this firmware, in particular into RTKit which is the most common operating system for this firmware.
Our 4-day version of the training, which we will give at BlackHat, has even more exclusive and new contents. For example, we include the forensic analysis basics for reading the sys diagnosis and analyzing how the system was used and how to get information about what the person was doing.
We are also open to discussing recent public research. With our training, you have the vocabulary to understand all the blog posts that you couldn't understand before. Register now for our BlackHat Europe training. If you make it before September 27, you will even get an early bird discount.